Hello friends, grab your coffee, grab your cookie, and make sure it is not covered in white dust, because today we are talking about alkali salt dust, that beautiful, shiny, harmless-looking white powder that quietly eats through metal, corrodes ducts, and sticks to every surface like it pays rent there. My name is Michael Klepik, and for 15 years I have been working with filtration and scrubbing systems that control salt and chemical dusts, from dryers, crystallizers, conveyors, and packaging lines. Let's take a closer look at what alkali salt dust is and how we deal with it safely. What alkali salt dust really is? Technical description. Alkali salt dust forms when dry salts become airborne during production, drying, crushing, or handling. These salts include sodium carbonate, sodium chloride, sodium bicarbonate, potassium carbonate, and similar compounds. Technically speaking, first, the particle size usually ranges from half a micron to about 200 microns. Second, the most airborne fraction is from 1 to 10 microns. Third, the bulk density typically ranges from 1,000 to 1,600 kilograms per cubic meter. Fourth, the dust is strongly hygroscopic and absorbs water from the air. Fifth, when it absorbs moisture, it forms sticky, crusty layers inside ducts and filters. So this dust behaves differently from inert materials. It reacts to humidity, temperature, and even small leaks in the system. Where alkali salt dust appears in industry, you will find alkali salt dust in a variety of industrial operations such as first, soda ash and sodium bicarbonate production plants. Second, chlor-alkali chemical processes. Third, salt drying and packaging facilities. Fourth, detergent and washing powder production. Fifth, glass manufacturing where soda and potash are handled. Sixth, fertilizer production using potassium salts. Seventh, food-grade salt refineries and conveyors. In all these cases, the dust is both fine and corrosive, and if you let it stay airborne, it attacks everything metal in sight. Why alkali salt dust is dangerous? The danger of alkali salt dust comes from its chemical activity. First, it is corrosive to metals and electrical components. Second, it irritates eyes, skin, and the respiratory system. Third, it absorbs moisture, creating sticky buildup that can block air ducts. Fourth, it can cause short circuits in electrical panels. Fifth, it lowers air quality and creates a fine haze in processing rooms. In some facilities, I have seen stainless steel corrode within months because of continuous salt dust exposure combined with humidity. Physical behavior of alkali. Salt dust. From an engineering standpoint, this dust behaves in three main ways. First, it is hygroscopic, meaning it constantly absorbs moisture from the air. Second, it cakes and solidifies on surfaces after absorbing humidity. Third, it forms corrosive solutions when mixed with condensed water vapor. Because of these behaviors, the system must maintain consistent airflow and temperature to prevent condensation and sticking. Duct velocities for alkali salt dust are typically designed from 3,500 to 4,000 feet per minute to prevent buildup. What filtration and scrubbing equipment works best? The choice of equipment depends on the exact salt and process conditions. For dry salt, handling. A BagHouse blizzard filter works well when humidity is low. First, it handles heavy dust loading. Second, it is easy to maintain and clean. Third, it tolerates crystalline particles. For these systems, I use filter media resistant to alkali corrosion, usually treated polyester or polypropylene fabrics, for humid or reactive environments. When moisture or chemical fumes are present, I use a wet scrubber such as the Tornado RP or a horizontal Boreas model. First, it washes dust particles with neutral or slightly acidic liquid. Second, it prevents dust buildup inside ducts. Third, it reduces both airborne particles and corrosive gases. Wet scrubbing is especially effective for processes with sodium carbonate or soda ash because it neutralizes alkalinity instantly. Material and design considerations. For alkali salt dust, the biggest design challenge is corrosion. That is why I always recommend, first, fiberglass reinforced plastic or polypropylene scrubber bodies. Second, polypropylene or PVC ductwork. Third, non-metallic fans and corrosion-resistant pumps. Fourth, plastic valves and nozzles wherever possible. Fifth, stainless steel only in areas with minimal moisture exposure. If you install carbon steel, it will corrode fast. I have seen systems fail in less than a year. The most common mistakes I see with alkali salt dust. Here are the mistakes that repeat across many facilities. First, using mild steel ducts and fans that corrode quickly. Second, installing dry collectors where humidity requires a wet scrubber. Third, allowing condensation inside ducts, causing salt to crystallize and block flow. Fourth, not maintaining constant temperature and humidity in the air system. Fifth, failing to ground the system, even though fine salt particles can carry static charge. Sixth, not cleaning the system regularly, allowing salt bridges to form. These issues always reduce system efficiency and increase maintenance costs. What I always do on alkali salt dust projects, my standard engineering approach includes, first, measuring the exact composition and humidity sensitivity of the salt. Second, choosing between dry filtration and wet scrubbing based on temperature and moisture. Third, using corrosion-resistant materials for all major components. Fourth, maintaining duct velocities high enough to avoid accumulation. Fifth, adding inspection ports for regular cleaning. Sixth, installing automatic drain systems in scrubbers to prevent salt buildup. Seventh, monitoring pH in the scrubbing liquid to maintain neutral operation. This combination ensures stable, long-term performance in even the harshest salt environments. Alkali salt dust may look harmless, just a bit of white powder, but it is one of the most corrosive and stubborn dusts in industry. It absorbs moisture, sticks to everything, attacks metal, and turns into a solid crust if ignored. But with corrosion-resistant design, correct airflow, and proper wet or dry filtration, it can be controlled safely and efficiently. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, salt belongs in your kitchen, not in your ductwork. See you in the next video.